Bonjour à toutes et à tous et bienvenue sur Radio Bean to Bar. Pour cette première émission avec des invités, on a l'honneur d'inviter donc Bhavani et Geneviève qui vont se présenter, qui vont parler de leur métier. Et on est ravis de vous accueillir. Thank you to be there. So, Bhavani parle uniquement anglais, donc on va mener l'interview en anglais et on espère que la traduction sera suffisamment correcte et authentique. Pour introduire cette discussion, moi, quand j'ai démarré le Bean to Bar, je suis tombé sur ce livre que mon épouse m'a offert et qui est de Megan Giller. Et c'est un livre en anglais qui m'a beaucoup inspiré sur l'histoire du Bean to Bar et qui m'a mis le pied à l'étrier, entre autres choses. Et donc, ce qui est rigolo, c'est qu'avec Geneviève, on s'est rendu compte que c'était une amie à elle et qu'elle a été surprise de voir ce livre dans notre boutique. Voilà. Et donc maintenant, je vais donner la parole à Sophia qui est avec nous pour mener l'interview auprès de nos invités. Merci.
Bonjour. So I will start the interview in English so that you can understand the questions. I would like to start with the question about your expertises. So what do you do in general, and if you can tell us a little bit about your company.
Okay, thank you. Thank you for having us. I'm very glad to be here in this beautiful Najak. It's an amazing place, and to imagine a bean to bar factory in a place like this setting 10 to 15 years ago would have been unimaginable, you know. And this whole movement of bean to bar is very exciting, and to be part of that movement and to have a little voice in this beautiful action that's going on is very humbling. And to be interviewed like this is even more humbling. And thank you for the opportunity, you know. And, to answer your question on my background, I'm a mechanical engineer by trade. And then I also got my master's in industrial engineering. The reason why I did industrial is because mechanical is mainly focused on a machine. And then industrial combines machines together for a full production line. So when you're thinking about a factory, you got to think about not only individual machines, but also the whole thing. And that's what was interesting to me, and that's what I did. And then after I graduated, and then I worked in corporate life for about 17 years. Mm-hmm. I did many different jobs. Within I did R&D for a big medical device company, and then in process development, and then I was also in manufacturing. I wore many hats within the same company. And then I quit about 11 years ago, and then I, happened to meet people that wanted equipment for the bean to bar industry, and I said, why not? I have time. Let me see what I can do, and that's how the journey started. Yeah. There you go.
Well, I would love to know a little bit more about this journey. How is it that you started working with specifically the stone mill? Why?
Yeah. So stone mills are very exciting in the sense that if you go to, like the Hershey Museum, mm-hmm. you see how they made chocolate 100 years ago. Mm-hmm. It was using stone mills. It's using stone grinders, And in the southern part of India, where I come from, that's where my background is. But I've been living in the States a lot longer than I was in India. What we use back there is the same type of mill to produce rice and bean batter to make a very special food called idli and dosa. And the reason why they use it is because you need to grind it very slowly, because it's a fermented product. If you grind it very quickly, the fermentation does not happen. The enzymatic activity doesn't happen. Mm-hmm. So they grind it slow, and then after it's ground up, they let it ferment. And then once the fermentation's done for overnight, then they make a crepe called a dosa, or idli, which is a steamed rice cake. Mm-hmm. And that's what they were using, but looks like somebody took the idea from one of these chocolate mills and made a rice mill. And it's like going in a circle, life is kind of interesting, Somebody gets an idea from somewhere and uses it in another part of the world. And then Now, back in the States, somebody saw this and said, hey, this looks like that, Why can I not use a rice mill to make chocolate, But where did it start from, is an interesting question. I don't know the answer where the concept of stone mill started, because I was looking at where, I live in a place called Grigstown, and in there's a, stone mill to grind flour, right? So we, as humans, have used stones to grind flours and batters for a long time, for a millennia, Yeah. So, the stones are part of the earth. They formed when the earth was formed. So I think we've all grown using stone mills at different times within our civilization. So I think it just went back a circle, So now it's coming back to make chocolate, yeah.
And so after you found this amazing product that I think it has been really useful for the bean-to-bar industry, why did you decide, or how did you decide to start a company from this?
Oh, yeah. So I didn't, I didn't make the connection. Somebody else did the connection of connecting the dots. But they were using the rice grinders to make chocolate. But the rice grinders are usually used for about an hour a week. They make it once a week or twice a week for about an hour. But then to make chocolate, you're running the machine 2 to 3 days nonstop, which is probably the life of the machine. So what you would use in a rice grinder for a year, you're using it in 3 days, right? So the amount of time, right? So the machines were not durable, right? They were breaking, constantly breaking. So one of the people who are using the machines, they reached out and they said, hey, I need spare parts for this rice grinder. I'm like, okay, why do you need the parts for those grinders? And that's when they said, oh, I'm making chocolate with it. So I said, oh, you're making chocolate. How do you make chocolate? And then that's how I got introduced to it. And then I met great people along the journey. And that's how it started refining the concept of taking something that was already there, in the mind of grinding stones, and then how do you make it suitable for chocolate on a small scale? And that's how the process journey started, Did I answer the question?
Yeah.
Okay.
The problem is that now I have a lot more questions. So you are telling me about how you started scaling down the process, making a machine to scale down for the specific use. But now that the bean-to-bar is growing, there is need to scale up again. How are you confronting this issue?
Yeah, it's not a scale down. What it was you had to redesign the machine. Okay, adapt the concept of a stone mill that was there and make it more durable for chocolate refining. And then one of the things I realized immediately was, as we were doing it, was we have to keep the machines very simple, but at the same time, make them very durable. So when you're in a place like this beautiful Najak and you're trying to fix a machine, you cannot expect to have like a technician or somebody who knows how to fix it. So it should be as simple as fixing a bicycle. So the concept was always about the artisan who's making it, because we're a startup company, and artisans are usually startup companies. They don't have a lot of resources. So we want to build machines that are durable, and if something's wrong, it's easy to fix and get it up and running with very minimal expense. So the design of the machine is such that you can replace every single component on that machine and you can keep it going forever. So your one-time purchase cost may be high, but then your long-term cost of ownership is very low. Because the cost of, you can pretty much replace everything on that machine and keep it going. Before, that was not the case, right? So you buy something, it breaks, and then done. You have to buy a whole new machine, right? So now how do you build durability in? So that's what we were bringing into the table. How do you build machines that are more durable? Not only that, then we started thinking about the stones, right? Okay, what kind of stones do we have to use? Because the stones that were used for rice grinding, because the time limit is much smaller. Now here, with chocolate, the timelines are much longer and the temperatures within the batch are much higher. There you don't want any temperature because you want microbial activity. So you're adding water and you're keeping the temperatures low. Here the temperatures are higher. So now you're talking about materials that can withstand the temperatures and also be able to withstand the wear and tear. So you don't want to be changing stones every 1 year, you want something to last for a very long time. Yeah. So we have customers who haven't changed stones in 8 years, 9 years. It's the same stones. And how do you design and figure those things out was what we were doing, Okay, what's the right combination of materials, material selections, and designing robustness into the machine. So now because of that, what's happening is our machines are getting very popular because they're very simple to use. Okay. It doesn't need a lot of extensive training. And because you can get up and running the same day, once you bring the machine in, it's just basically a plug and play. You plug it in, you turn it on, you put it, and you start. You watch a YouTube video, and then you're on making chocolate. So your accessibility to that product, making the product becomes easier. Mm-hmm. That's what we were focusing on. So I think we're there, but I think more work needs to be done, and we're still continuing to do that.
So it's good deal, and I don't want to just make promotion, but it's good stuff. Very easy to carry. Also about the weight, it's very easy to move everything. And
it's about 50 kilos.
Yeah, it's not heavy, at all.
Because you can take the bowl and the stones out.
Yes.
Once you take it out, it's a lot more easier to carry. Yeah.
Yes.
Yeah, we're very happy with that machine. It's a little tank. We've been making some changes to it. We've been making some
because I met a friend who worked with the first Marque.
Yeah.
And this is a Mark II.
Yeah.
And we compared the wheels.
Yeah.
You decreased the size of the wheels.
Yeah.
Probably is that about this idea of movement?
Yes, because what was happening was when you look at the ratio of space inside the bowl to the space inside the stone was taking up a lot of space, and that kind of created dead spots within the bowl. When you don't want dead spots, you want stuff to move around everything. So that's why when you look at our design, we have very little metal pieces inside the bowl. And we don't like to have a lot of pieces inside, because the more you add to the component, more stuff will find ways for it to accumulate.
Okay.
It's a dead zone.
Yes.
You don't want dead zones. You want everything, because you want the particle size to be uniform. Mm-hmm. Right? When you take a distribution of your particle sizes, you need to be in a very tight band, right?
Yes.
So that's the goal. When you have a lot of dead zones within a melanger, then stuff will get accumulated in corners. In that corner, the particle will be much thicker. It won't be refined as in other portions. So now your chocolate has a lot of variability. So we didn't want that, and that's why we kept the inside of the bowl with very little pieces inside, so things can flow around. And that's one of the reasons why we reduced it, so to increase the flow.
Okay, great.
And the other thing we're also working on the machines is, some people use sugars, which are very difficult and tricky to use.
Like what sugar?
It's like date sugars and things like that.
I use some.
Yeah, and one of the things is when you're having, and it gets very aggressive, especially when you have the stone on the bushing area and it's pressing, because the temperatures in that area is much higher than the rest of the batch. So in those areas, what happens is you'll have crystallization happening with alternate sugars, because the cellular structure is different. And at temperatures, their properties change quite a bit. So one of the things we're working on is adding bearings to the wheels. So now we've been testing them for about 4 years, and we've had really good success. And now we're sending it out to a customer here in France for her to test it. But the goal is to slowly move away from the plastic bushings. Because that's another concern that we keep hearing from our customers is like, hey, it is plastic, but bushing is a bushing. But as I was saying again, when the pressures are low and you keep it the way, you had it for 2+ years or 3 years, you saw there's not much of wear and tear because the pressures are low. Yeah. So if you keep the right amount of pressure, the components will last a long time. But even then, there's always some wear and tear. So now the idea was, how do we get away from that? It's about constantly finding ways to improve the product. One of the things was we figured out that we can work with, food grade components that we can source. They're a little expensive than a simple plastic bushing, but then your performance will be better. is the goal. So we're having a bigger wheel in France next week, and also a smaller one tested. And if it works out, then I think it'll be available for everybody to purchase. So you can upgrade it,
Yes, I'm really excited about it. Yes, because it's a concern to us about plastics, especially on the small, the premier that is very. It goes faster to the bigger machines. About
that's the nice thing about the bigger machines is you have the variable speed, so you can control the speed.
Yes.
Because you control the speed, you can control the temperature. It's all about time, temperature, pressure, right? And also the speed of the motor that it's spinning at. That's what controls your process. So now if your temperatures are going up, on a Premier you have no choice. You're stuck. Whereas with the bigger machines, like we have the new DCM15, if the temperatures are going up, you can slow it down, right? When you slow it down, you're not changing the pressure, because if you change the pressure, then you're losing your refining, right? You don't want to lose your refining capacity. You want to keep refining, but you want to lower it, the temperature of your refining.
Yes.
So you slow it down a little bit, and you have the flexibility to do that. And that's the nice thing that we're trying to offer on our DCM line. So that, again, the plastics on the Premier, we also have a stainless upgrade on those that you can use. That's also another option.
I am happy that you mentioned the material, the stone that you use. I know that it's often used, I don't know the name in English, but the volcanic stone. Mm-hmm. I would like to know a little bit more about which stone is it that you're using.
Right. So, I don't know the exact geological name and things like that. So, the stones are, it's a type of a granite we use. And, the granites are formed when the earth was formed. Mm-hmm. It's one of the oldest material that's there on planet Earth. It's very, very stable. You see the pyramids, you see all these things that are built, and they cut granites, and they've been standing there forever. Mm-hmm. It's a very stable material, but at the same time, it cannot handle huge temperature spikes. So if there's you have a stone that's really hot, and then you pour a lot of cold water on it, it cannot take the temperature shock. Mm-hmm. But as you gradually increase the temperatures and gradually decrease the temperatures, it's totally fine. But it cannot withstand. It's a metal will expand.
Okay.
Right? The stones cannot. So other than that one drawback with the stone, it's basically granite. It's beautiful. It's a beautiful material to work with.
Mm-hmm. So I want to start focusing a little bit about this specific machine. You are talking about how there's no need to change them so often, but still there might be some kind of wear or deterioration. So what kind of deterioration can we find? When is it necessary to change a piece? How do we know as artisans that it's time to change a piece or the machine?
Right. So, great question. Typically, when you're running these machines, everybody thinks it's the stones that do the grinding. Stones facilitate the grinding to happen. So if you think about it, you have a big bowl of chocolate or whatever you're grinding, and the contact surface of the stone onto the bedstone is a line contact. Mm-hmm. It's a simple line. Okay, there are two lines that make contact on the bedstone. And to think that entire batch of chocolate is getting cut on that very thin line is not true. What is happening inside the machine is, it's like sharpening a knife. I like to tell this example a lot. When you sharpen a knife, what do you sharpen it on? You're sharpening it on a stone. Right? When you sharpen it on a stone, what are you using? You're using some water or some fluid like oil or something like that. And then you put some pressure on the knife, right? Mm-hmm. And then you move it back and forth, right? It's the motion, right? The friction. And then motion, the friction that it creates this black fluid, right, on the surface of the knife. Mm-hmm. And that fluid is actually the knife itself. Right? When you put too much pressure on the stones to let the stone cut the knife, your edge is very jagged. Mm-hmm. You don't get a clean edge. But when you just apply just enough pressure and go back and forth, and you let the knife cut itself, then you have a very precise edge. Okay. Right? So it's the same concept. You don't want the stones to grind your chocolate, but you want the stones to create an environment for the chocolate to grind itself. Okay? So what do I mean by that is you're creating motion, and you're creating friction, and you're creating competing activities of friction inside the bowl that will create your fine. Everybody asks me, can I go down to 20 microns? You can, because as you keep on going, it'll keep on cutting because it's grinding against itself. So as an artisan, what my job when I'm designing the machine is to design it such a way, it's like doing a gardening. You know, you lay the foundation, you have beautiful soil, you get beautiful seeds, you have the nice setup, and then once you plant them, you let them be, and they will grow. It's the same thing with chocolate. Once you have the right setup, you let it do the work, and you will have beautiful chocolate because things will happen on their own. And that's what we want. So if you use the machine the wrong way, you know, yesterday we had a great conversation, right? Yes. I mean, we said, oh no, this is wearing out. And then we take out the stones and we're looking at them, there's no wear. Okay. And that's because if you just have just enough pressure, that pressure is enough for the action of shearing of the components to happen without the components themselves shearing down. It is a shearing machine. It is a machine designed to shear. So if you don't give the ingredients to shear, it will shear itself. Right? So you have just to give you an example of a ball mill, you don't run the ball mill without anything because then it'll wear itself down, right? Mm-hmm. It's the same thing. You don't run the stone grinder without anything inside. It'll wear itself down, right? At the same time, so it will shear anything. So the key, that's why you're able to shear nuts, you're able to shear coffee, you're able to shear rice. They say, oh, it's a rice grind. No, it's a machine that can shear. Mm-hmm. Anything you put inside, it will shear. As long as it's able to have what? Motion, friction, and the right temperatures. Once it has those elements inside, things are going to start happening.
Okay. Question.
Yeah.
Do you think when I start a new batch, I should change my setup about pressure? Like I start a new, so I release and then put more pressure later, or just always the same?
Yeah, that's a great question, right? So pressure is a very important point. And one of the things we realized over time is that artisans were having a hard time dialing the pressure. Like, when do I add pressure? Do I add it in the beginning? Do I add it in the end? Do I back off the pressure? How do I do it? So then we said, okay, we need to come up with a very simple way that they can dial the pressure and leave it. Because now you're getting bigger, like you were saying, you're expanding. Now you're going to have, you as an artisan, you're able to taste it, you're able to see it, you're able to figure it out. Now you have somebody else working on it. How do you repeat the process, right? So then we said, how do we do it? We said, okay, we got to put some kind of a system, like a pressure system, that's always constant. Because the key is consistent pressure. Because if the pressure varies, your refining times will vary. Think about the knife example, right? If you don't put enough pressure on the knife, it's not doing anything. If you put too much pressure, then the knife is getting cut in a weird way. You don't want that either. You just want the right pressure all the time. So it's not at the beginning, it's not in the middle, it's not the end. Just have the right pressure, then that pressure will do magic. And so that's why we have this little pneumatic system. It's not very expensive to add on. You add that on any machine, and then you set the pressure and you leave it. And then it'll do the job. The way this machine works is there's a spring in the middle that's applying the pressure onto the stones. And if you apply too much pressure and compress it all the way down, and this spring is compressed, now the stones don't have the ability to move up and down, and they get stuck in place. And when they're stuck in place, now there's tremendous amount of downward pressure, and also it needs to rotate, and there's pressure from inside the ingredients. So now you have competing amounts of pressure acting on the stones, the bushings, and everything else, and you have components wearing out a lot faster. So one of the things we tell our customers, we've designed the spring such a way that when you tighten it just, so this is a technique. I'm going to loosen it all up, so all the way out. So it's free. There's no pressure on it. Get it to the point where it's touching, and same thing on this side. Once it's touching, just go a turn and a half. And the same thing on this side. Go about a turn and a half. And that's all the amount of pressure you need. That equates to about 70 pounds of pressure on the stones. And that amount of pressure is all you need. And then you lock it up. You put a double nut on it, and then you lock it up. And then once you lock it up, you'll be in good shape. But again, the question is, does it vary? Because now what happens is the spring is compressed just a little bit. Now as the ingredients are added, the stones will lift up and the spring will get compressed even more, right? So now it moves up and down on the variation of the particle size of the ingredients. And as the particle sizes get smaller and smaller, the stones will slowly settle down. And when they're settling down, the spring is not applying the same amount of pressure when when the particle size is bigger. So that's why when you have a pneumatic system, the pressure is always constant. Because the pressure is always constant, your refining times are always constant. Whereas here, you have to come back and see, hey, is the pressure still on? Is it not? Do I need to add a little bit more pressure? So you have the variability that you can avoid by having that simple attachment.
Okay.
Would the pressure change if we change our ingredients? For example, do we need a different pressure for white chocolate or for chocolate with milk or for black chocolate?
No, because one thing you're trying to do is you're always trying to grind something. You're always trying to refine something. Like I was saying, it's a shearing machine. It'll grind anything down. You have to give it the right ingredients and have the motion inside, and it'll refine it. You can give it anything you want. It'll do it. So the key is this, right? When I'm refining something, the question about how, when I'm putting milk chocolate, for example. So if you're just adding all the solids in and not the liquid to go with it, then it's not going to have the motion. So more than the pressure, my thinking should be, what is the order of ingredients that I'm putting into it? Because you're on the back of your mind, you're always thinking about three things: motion inside, how much friction am I creating? So the other thing is, some people do what they do is they add all the cocoa butter in and they make it very fluid. That means now you have very little friction. Mm-hmm. When you have very little friction, the shearing slows down. Yeah. Right? So you have to think about the order in which you're adding ingredients more than how much pressure I'm putting. Mm-hmm. That becomes the key. So for example, I had one time a customer they were making white chocolate and they had coconut flakes. And they said they were running for 5 days and the coconut flakes are never grinding down. I said, okay, when did you add coconut flakes? Oh, I added it at the end. Okay, how much butter? Cocoa butter. Oh, I have this much. So the coconut flakes are very light in weight. Mm-hmm. What does it do? It floats. So it'll never get down, right? Yeah. So you have to think about the viscosity that's inside your bowl all the time. That's what your keying should be on. Pressure, once you set the pressure, you forget about it. Okay. Your focus should be on, am I creating the right conditions for the refining to happen? As a gardener, am I creating the right condition for my plants to have the best success? And that's what you're doing. Am I creating the right conditions by the amount of ingredients and sequence of ingredients? So you don't add all the cocoa butter in one time. You add it slowly. You create the paste. You make the fluid. You make the shearing action going on. Then you slowly build it up. You don't want it to be too fluid where everything is sloshing around. And if you do that, it doesn't matter what chocolate you're making. It doesn't matter what ingredients you're adding in. It's always, that's your baseline. What is my motion inside and how much friction I'm creating? Did that answer the question?
Yes, no, very well. Yes, just to testimony, it's it's nice to understand how it works instead of I think I was missing informations about what happens really.
No, in the sense like it's a great thing too, because we don't know everything, right? And we're also learning by coming and visiting people like you. We are so thrilled by coming and seeing your operation. And 15 years ago, this would not have been possible. To do a bean to bar and in a place like this with the logistical issues you have, with the supply chain issues you have, and the factories, this location, the space constraints you have. But you're fighting through all that and making it happen makes us feel like we're doing something right, makes us feel very happy, Not only that, but it also teaches us. Like, hey, he's doing it. And this is the learnings that we have had over the years. So maybe when you bought the machine, we didn't even know to tell you this because we're also in the same journey as you are. As we see these things, we're like, okay, this is what's happening. Like this coconut flakes thing, I would have never imagined, right? But when a customer comes and tells me, hey, I'm learning from you guys, right? And that's how that's the joy for us is, hey, what is working, what is not working? How can we make this better? And that's the life pursuit, I guess, how do we make these machines better constantly? So that's why when you bought the machines, maybe we didn't even know to tell you these things, So maybe we should meet often like this and we should discuss.
Before you mentioned a little bit about the ball mills, and I wanted to ask about the different kind of mills and if this specific stone mill will have any different effect than if we use, for example, the lint machine or with the cylinders or the ball mill. Would the product be different? Is the process going to change a lot in times or?
Great. I mean, I think it's an amazing question because as chocolate makers, one of the things that happens is, from what I've seen is you're manipulating cocoa butter, right? So cocoa butter behaves completely differently at different temperatures. So, different machines have different temperatures in which they operate, right? So when we're working with a stone grinder, in traditional ball mills and traditional machines, right, you have a refining step and then you have a conching step, which is a step because the refining happens so quickly, then you have to get the acidity out and then you conch it in a conching machine, right? So it's two separate steps. But in a stone mill, like in our type of melangers, what happens is the acidity is coming out as it is refining. So it is conching and refining. Yeah. So now, depending on what temperatures you're running your machine, even in our refiners, you can change your conchability of your product. So to answer your question, will they be different? Yes, they'll be different because the amount of air that interacts with the chocolate is different. And the temperatures that the chocolate's getting exposed to or it's getting processed is different. So the end product is different because, the acetic acid and the acids that are inside, as they're getting ground up, they're mixing with the open atmosphere and also with the moisture in the air. So that changes everything, right? So I know people have tried to create a recipe on a stone mill and then tried to recreate it on other machines, and they have had a hard time. And they've spent a lot of time trying to do it. And so there is a difference. And, can we equate? Maybe difficult or maybe, I don't know. Because I haven't worked with the ball mill, so I don't know. But this is based on what I've seen.
Thank you very much. And so before as well, you mentioned that basically everything in the machine is made to be easily repaired, easily changed. So I want to know which parts is it that we should change, how should we change them, and if it is us that should change them, or if we should call you to change them yourself, which parts specifically, one thing or another?
Yeah, so, the way we've designed this machine is that an artisan or somebody who can use a little few tools with a little video help should be able to pretty much take the entire machine apart and be able to put it together within a few hours. So it's not like days on end, but it's in a few hours you should be able to take everything out and be able to put it back together. We were in a factory a couple of days ago. We were changing the bowl out. We would sit, half an hour? Maybe. We replaced the whole bowl on a big machine.
The bowl?
The entire thing.
Wow.
Took it out and put another one in. So everything is designed such a way that you can take them out and replace. The only thing, if there is any kind of scheduled maintenance, is, if you had used too much pressure and if the stones are showing wear and tear, there are videos on how to renew the stone, to bring life back to it. So, it's about cutting certain grooves in it and making those things happen. And there are videos on our website, videos that we can share, and to bring the life back to it. The rolling stones nothing should happen. They should last a long time. But if there's too much pressure, they'll wear out. Mm-hmm. And if they wear out, you just take them out and put them in. It's just 2 screws that hold them. And some of our newer machines, we're even going away from screws, and it's just a pin that holds it. You take out the pin and put a new one in, and you're back in business. And the motor should last you a long time. And if the motor goes, it's 4 bolts. You take out the motor, put a new motor in. So everything is designed around being very simple to change and replace. You take one out, put another one in. And you should also be able to take parts from another machine and put it on this machine, and it should fit. So you can put parts across other machines, and they should all work.
Okay. And I imagine we can find all these replacements on your page.
Yeah.
Would you like to give us the name of the webpage so that...
Melangers.com.
Perfect. Thank you very much.
Take it apart. We took this apart and we used some really hot water to wash everything down and then to clean it with a rag. And how many tons did you say you processed through the machine?
I probably passed like 3 tons of cacao, something like that.
Yeah, and the blade still looked good shape. Everything looks good. It just needed cleaning. That was the only thing that we had to do.
Yes. Yeah. When we opened it, the blade was really clean, and I thought, okay, it's fine. But when we opened like this part here and further, we saw like dust, sticky, a little everywhere. So it was nice to.
Yeah. So the one thing is, we always like to use the cacao that's completely dry, cocoa bean, after roasting, and cool down. We don't want to use a warm bean. Because with the warm beans, the thing with the warm bean is the bean itself tends to be supple. It tends to be flexible when it's warm.
Yes.
When it's cold, the cocoa butter solidifies within the bean, and it has a nice crack. Mm-hmm. And also, one other thing that the cocoa butter does is, as it cools down, it shrinks back into the bean, so it makes the husk very light. So there's not a lot of fat in your husk. So you want all your fat in your chocolate, in your nib. So the ideal thing to do is to cool it down. Once you cool it down, then the bean is harder and the cocoa butter is with you, not in the trash, in the husk. Mm-hmm. So your chocolate's much better. So that's one thing. And also it helps with the cracking, because now the bean itself is brittle because it's cold. It cracks nicely, and then we are able to get the maximum efficiency on the machine. Okay. And one of the things we were talking about today was also how to calculate efficiency.
Yes.
So the easy thing is to take a small 25 grams of your bean that you're going to process and peel it manually and see perfectly, yes, in your hand, and say, okay, how much is the husk? How much is the nib? So you know what the nib weight is for that bean origin and what is the husk weight. So now you run through your machine, you should have about 4% loss. Okay? If
compared to
manual peeling.
Perfect one. Right?
Okay? So you should not have anything more than that. If it's more than that, there's something else you need to do. But the way we've done it in all our tests is that we could not get anything better than 96% efficiency, which is 4% loss compared to manual peeling.
Okay.
Right? And we were able to repeat it over and over and again.
Okay.
So again, today we can repeat it. We can do the same thing. We can take some.
Yes.
We can peel by hand. We can weigh it.
Let's go.
And then we can run it through the machine, and then we can see whether we get the high 90% efficiency that we always get.
Okay, let's do it.
Let's do it.
And talking about the life cycle of the machine, you mentioned that someone was able to use it up to 80 years. Is it that we can use it for even longer? Can it last a lifetime? Or how often should we change the entire machine?
The machine should pretty much last a lifetime because every component is replaceable. Yeah. So if something is wrong, you can replace it. And the component costs are not high. So you buy a machine and it's just good for ever because you should be able to replace pretty much everything on the machine and keep it going. I haven't seen a situation where a machine could not be repaired and it's in such a situation where you have to throw it away. But our design build on the machines is such that we're in a society that tends to throw things away, and they tend to build in the life cycle of where it fails after a certain time, and then you can't use it. And we went against that. We said, no, we want to build machines that will last for a long, long time, and as long as we're able to find the components, we should be able to service them and keep them going.
It makes me really happy to hear this. It's amazing. Do you want to add any other questions?
Yes. What are your new projects you are working on? Because I have from the smallest to almost the biggest, not now, but soon, I hope, your stone Melangers. And I have also about the winnower. We didn't talk about winnowing. It would be interesting to talk about. We are going to see after the machines. But are you working on new projects? What are in the tubes?
Yeah, great. So people are asking us, hey, can you build us a bigger one than this? And so we're working on that. So we're working on a DCM 250. I don't know. I'm not sure if we'll end up with 250. We may end up with 225. At some points, there's a design element, where it becomes so big that it's not. So one other thing that we really take pride in is how we package everything and how we ship everything around the world, right? So it's small, it's compact, and it's easy to transport. Now, once you get to be very big, then it becomes massive, and then the logistics get very tricky. Not only the logistics part, but also the design element part, the machinery becomes a little tricky. So there are a lot of things that change after a certain size. So we think at about 250 pounds, we're at that limit. Maybe if you ask me a few years down the road, maybe we've figured something out and they said, no, we can go to 300 pounds. I don't know. But right now, I think we're at 250 pounds. We're comfortable. And that's where we're working on. And that's very exciting for us. And mostly it's the nut butter guys love the bigger size. They want bigger and bigger size.
I wanted to ask as well about your clients. I understand that you work in New York, but a lot of your clients are somewhere else. So where are the most part, and what other uses do these clients give to these machines?
Great question, right? One of the things that give us the biggest joy is seeing these machines being used in origin. Because I used to, work in my previous life. I was traveling to the DR, and we had a little celebration with my production line, people. And I asked them, what can I bring as a gift? And they said, bring apples and chocolate. I said, apples and chocolate? You guys have cocoa growing in your backyard. Why? They said, no, because the cocoa grows here, but we don't have chocolate here. The cocoa gets exported out to Europe and to Americas, and then it gets converted into chocolate. And then by the time it goes back as finished product, it's very expensive. Yeah. They can afford it. So now we see that our machines are used in tiny villages and in farms. You see a bucket and then a machine sitting on top of a bucket making chocolate. Yeah. So we see that happening, and that gives us the immense joy because that is kind of like giving back. So now a person who didn't know fine flavors is figuring out fine flavors at the farm. Before, they didn't have tools to do that. Now with our simple machines for a few $100s, they're able to refine, and they're able to taste it, and they're able to say, oh, my fermentation, my process is having this impact on this chocolate. But if I change it this way, it is changing, the outcome. So now I can get more money for my cacao, So that's another interesting thing that's happening. So, from an organization standpoint, when you see machines in origin, that gives us a lot of pressure, but also it gives us a lot of pressure when coming to a place like Najak and seeing the machines being used here and the way it's being used here, it gives us immense joy. And that's kind of our customer base,
Du coup, c'est le moment d'introduire Geneviève dans la discussion.
Oh,
yes, c'est son moment. It's her time now. Et donc, Geneviève, est-ce que tu veux bien te présenter, s'il te plaît, et ton rôle dans la société DCM?
Oui, bien sûr. Donc moi, je suis en fait originaire de Belgique, mais j'habite à New York, j'habite à Brooklyn depuis très longtemps. Et j'avais une profession de designer pendant des années, puis j'ai toujours en faisant du chocolat sur le côté, et on était intéressé par ça. Puis plus récemment, j'ai commencé une petite société de dégustation et d'éducation sur le chocolat, et j'ai aussi développé quelques produits. Je travaille beaucoup avec la pulpe de cacao parce que ça m'intéresse et je voudrais que les gens à qui je parle connaissent ce goût-là. Donc j'ai commencé à travailler sur ce produit. Et puis voilà, j'ai rencontré Bhavani et toute l'équipe. Et comme je parle français et anglais, et que ici on a quand même une clientèle qui se développe très très fort en France, bien sûr en Belgique, dans les pays d'Afrique, dans les îles, beaucoup de francophones. Moi je peux aider pour ça, parce que ça, c'est sûr qu'on peut tout faire en anglais. Maintenant à l'ère de la traduction automatique, c'est faisable, mais je pense que c'est quand même important d'avoir une communication personnelle, parce que nous on aime bien avoir on aime voir les clients, on aime discuter, juste comme Bhavani disait, on aime bien apprendre aussi de nos clients. Je trouve que c'est très important d'avoir une conversation. Donc moi j'ai commencé il n'y a pas tellement longtemps, mais je suis là pour ça, pour essayer de mieux communiquer, disons, avec la francophonie dans le monde. Et je trouve ça très intéressant parce qu'en même temps aussi, j'apprends des gens. C'est quelque chose dont je peux me servir, moi, pour mon rôle d'éducateur. Je peux aussi peut-être aider les gens de temps en temps avec ce que je connais. Donc voilà, c'est un peu ça mon rôle.
Et alors, est-ce que tu peux nous parler un petit peu plus sur la pulpe pour que les gens comprennent un peu mieux?
Oui, bien sûr. La pulpe de cacao, donc c'est ce qui entoure chaque fève. Et c'est un produit qui est pas encore tellement connu, qui n'est certainement pas très utilisé. Et moi, je trouve que c'est un produit important parce que c'est un produit qui est très fort discarded, jeté en fait. Forcément, on n'a pas besoin de 100% de la pulpe pour faire la fermentation. On peut très bien utiliser 20-25% de la pulpe et continuer la fermentation avec ce qui reste. Donc, s'il y a moyen d'utiliser ce pourcentage de pulpe au lieu de le jeter ça apporte de la plus-value évidemment au cacao pour tous les planteurs. Donc, je trouve que c'est important en fait de pouvoir utiliser et donc amener cette plus-value. Et puis en plus, c'est un produit hyper délicieux, intéressant, que je trouve qui n'est pas justement suffisamment connu. Donc, autant faire quelque chose de bon, quoi.
Et comme quoi? Qu'est-ce qu'on peut faire?
Voilà. Mon cheval de bataille, c'est les caramels. Okay. Alors, la pulpe, ça s'appelle baba.
Ok.
La plupart d'Amérique du Sud, Amérique centrale. Donc, je les appelle les babamels. Et puis, je fais, avec les babamels, bien sûr, après, c'est venu la crème de babamel. Donc, là, c'est la sauce caramel à la pulpe. Puis, je fais aussi des petits pots de ganache que j'appelle baba ganache. Donc, ça, c'est la pulpe et le chocolat ensemble. Donc, là, je me fournis chez un producteur de bean to bar, bien sûr, parce que moi, je ne fais pas le bean to bar en plus du reste. Ce serait beaucoup. Donc, je mélange ça ensemble. Et puis, je fais aussi des bonbons, bien sûr, fourrés, soit au caramel, à la pulpe, soit à la ganache. Et puis, on va voir, je continue un peu à réfléchir quand j'ai le temps après le travail.
Est-ce que tu peux décrire un peu les goûts des babas, de la poule?
Oui, bien sûr. Bon, ça dépend aussi un petit peu de d'où ça vient. Hein. Les différentes pulpes ont certainement différents goûts. Moi, j'en ai goûté plusieurs. Ça, ce sera pour une autre étape, de pouvoir faire des différences entre les différentes pulpes, comme on fait la différence entre les différents cacaos. Mais ça viendra bien plus tard parce que c'est donc toujours un peu compliqué pour pouvoir acheter la pulpe. Donc là, je travaille avec la pulpe d'Équateur. Donc les goûts, c'est vraiment... Il y a beaucoup de pommes vertes, de litchi un petit peu, de ananas aussi. Je dirais, c'est un peu un mélange de ça. Un petit peu peut-être... C'est assez acide, hein, donc il y a une très belle acidité, un peu genre fruit de la passion, qui passe aussi. Donc, voilà.
Super. Donc voilà, à tous nos amis francophones, si vous avez besoin de communiquer en français auprès de la société DCM, voilà, vous pouvez contacter Geneviève. Et il y a un contact direct ou on passe par le site
Non, j'ai le contact direct. Oui, vous pouvez bien sûr passer par le site, mais le contact direct, c'est mon nom, c'est Geneviève, à melangers.com, notre pub. Donc, quoi que vous ayez besoin, moi je suis là.
Voilà, le lien est fait parce que j'avoue que moi, par exemple, en anglais, j'avais pas forcément tout à fait les bons mots, notamment le mot facture. J'étais à Bhavani bill. Et en fait, c'était invoice. Et donc, en fait, j'ai bugué pendant un certain temps par WhatsApp avec Bhavani pour comprendre que je me plantais, quoi. Ouais, voilà, c'est ça. Donc, comme quoi, c'est pratique quand même aujourd'hui. Voilà. Est-ce que tu as d'autres questions, Sophia?
Je crois pas. On peut finir avec une petite dégustation, alors.
C'est ça, on a fait une petite dégustation. Qu'est-ce que tu nous as préparé?
Et on a ici quelques petits cristaux d'amandes. C'est des bâtonnets d'amandes caramélisées, c'est enrobé de chocolat. On les a en noir et en blanc. Et après, on a une tablette de chocolat de Barra, El Salvador.
Barra Cigar.
Et une tablette de chocolat blanc aussi.
D'accord. Et donc là, on est sur un noir 77%.
Noir, 77%. Et l'enrobage aussi. Okay.